Welcome to this course on AI. As we mentioned, let me first start today with the syllabus that we are going to cover, and we did a little bit of this in the last class towards the end, and I am just repeating this for continuity. So, we will spend the first few weeks, not 2 or 3 lectures, on the first part of the course, which is the history and philosophy of AI, and as we will see, it goes back quite a bit in time, and this is qualitatively going to be very different from the rest of the course, which is going to be mostly algorithms. And we will start with the simplest algorithms like depth first search, breadth first search, and so on. Move on to heuristic search, in which we look at how search can be guided towards the solution that we are trying to find, and we will look at algorithms like hill climbing and taboo search and things like that. We will find that even that is not going to be good enough. So, we will try some randomized approaches like simulated annealing, genetic algorithms, and ant colony optimization. These are basically optimization techniques, but we will try to see them from the search perspective. Then we will look at a very well known algorithm called A star and its variations, which we will see. Then, as I mentioned earlier, that we will look at something called goal trees or problem decomposition, that if you want to solve a problem and you want to break it up into parts and solve each part separately, that technique is called problem decomposition. It led to an area called rule based systems, which we will look at essentially. We will also do game playing, perhaps not as late as this, maybe somewhere here, so that I can give you one assignment to start off with, which is to implement a game playing program. And finally, depending on how much time we have left, we should have something on planning and constraint satisfaction, which is kind of a preview of the course that we offer next semester, in which we will study these algorithms like alpha beta algorithm, minimax algorithm, and a heuristic version called SSS star. And then depending upon how much time we have, we will spend some time on these two topics, planning and constraint satisfaction, in which we look at general algorithms for planning. And we will see, by planning essentially we mean finding a sequence of actions which does something useful for you. And we will also look at logic and inferences, because it is not that we are just solving problems of how to do things, but we are also making inferences that if we know something, then we know something else. So, that is a process of making inferences, and the language that we use for representation is logic, and we will spend some time that. So, these two topics are actually covered independently and completely in two different courses that we offer next semester. One is called planning and constraint satisfaction, and the other one is called knowledge representation and reasoning, which is not the title we are using here. So, the textbook that we will follow is the book which I have just published. It's just about come out, and there are some textbooks in AI which have been very popular, and earlier I was using a lot of material from here. So, Rich and Knight book on AI, Russell and Norvig, which is probably the most well known textbook at this point of time, and a book by Winston which was written earlier. Then there are certain specialized books. So, these two books by Fogel and McLevis is on certain aspects that we will cover, and this book by Julia Pearl is something we will use while game playing essentially. And these two books, which I will just mention again, deal with the history and the philosophy part of AI essentially. Yeah, so these two books that I mentioned, and this is going to be the subject matter of the first few lectures, the historical and the philosophical perspectives to AI. And you can see that it is a topic, because we use this word intelligence here, and that is something which has concerned people over a lot of time essentially, and we want to see what has been the thoughts behind what is AI essentially. So, these two books are, and I would recommend that you read at least portions of this. There is a book called AI the Very Idea, and we will discuss shortly why this book is different from the rest. John Hogeland is a philosopher by profession, not a computer scientist, and he is looking at the philosophical side of things. That one of the key questions we will ask, and today we will start doing that, is can machines think? I want you to start already thinking about this question, and today we should discuss some of these basic concepts. What is intelligence, for example? And Hogeland looks into the philosophy behind this. Pamela McCorduck is also from the social sciences, and she wrote this book quite long time ago, actually 1974 or something like that. And I hope you will notice that the title is, if nothing else, at least a little provocative, because she uses the pronoun who for machines. So, she says machines who think, and who is something that we normally use for people, essentially human beings and so on and so forth. So, she is talking about machines who think, not machines which think, for example, and therefore, already there is a suggestion that her own inclination is to believe that yes, it is possible that machines can think. And these two books we will follow, and the slides that I have prepared are mostly from these two books and a little bit from Wikipedia. So, I will give you all the sources. For the rest of the course, I will not use slides very much, we will just discuss things on the board essentially. So, I want today's class to be a little bit interactive, well, not just today's class, but today's class to be more interactive, and I wanted to start thinking about the question of what is intelligence, and we will discuss that. But before we do that, let us just look at what are the classical definitions that people have given for this field of artificial intelligence. So, let us see first what Herbert Simon has to say. Herbert Simon was one of the founding persons in this area of AI, starting in the 50s, 1950s. He and his collaborator Alan Newell, they founded the school at Carnegie Mellon University, and we will see their contribution as we go along. Simon also one of the few people who works in AI who has got a Nobel Prize. As you know, we do not get Nobel Prize in computer science, but Simon got one for economics, and he was a multifaceted person. He did many things, as people used to be earlier. So, his definition is we call programs intelligent if they exhibit behaviors that would be regarded intelligent if they were done by human beings. So, this is the most common definition of AI that people use, that it is concerned with writing programs or making machines do things which would be considered intelligent by if they were done by human beings essentially. So, one of the first things that AI people got into was things like chess playing essentially, because chess playing was always considered to be a hallmark of intelligent behavior essentially. It is only the bright and the intelligent people who could play good chess. There is a long story of chess playing. The first programs were written in 1950s. One of the first outline of the game was given by von Neumann. In the 60s, a grandmaster called David Levy, I do not know whether I have it in my history, but maybe it will come later. So, let me just write it here. I think around 1968 or so, he wagered a bet that a chess program can not beat him for the next 10 years. Because chess was considered to be something which is very intellectual in nature. Well, luckily for him, he won his bet, which is because it ended in 1978. But many of you would know that in the mid 90s, late 90s, the then world champion Garry Kasparov was beaten by a chess playing program especially. Chess in fact is not so, it is not so intellectual in the sense that we tend to talk about, philosophical sense. Yes, it requires lot of computing machinery, and we will see that if you have a lot of computing machinery, you can play good chess. Let us look at another old definition. This is by Barr and Feigenbaum, also two old timers in AI. So, his definition says that physicists ask what kind of place this universe is and seek to characterize the behavior systematically. Biologists ask what it means to be a physical system to be living, and he says we in AI wonder what kind of information processing system can ask this such questions essentially. So, in other words, he is talking about intelligence, that physicists are asking questions about the physical world, biologists are asking questions about the living creatures. What kind of information processing system could ask such questions? So, essentially he is saying what kind of system would be intelligent in that sense of the world essentially. Then Elaine Rich, as I mentioned, one of the popular books in AI, she wrote one in 83 or something or 86, and she gives a computer science flavor to the definition. She says that AI is a study of techniques for solving exponentially hard problems in polynomial time essentially by exploiting knowledge about the problem domain. Now, of course, those of you who are die-hard theory people would immediately object, saying that you cannot solve a hard problem in polynomial time, because by definition it is a hard problem. But there are two counters to this. One is that we may not necessarily be looking for solving them in polynomial time in the worst case. In certain situations, like we will see, travelling salesman problem is one of the hardest problems that people have encountered, but given some constraints on the problem of how the edges are connected, what are the weights on the edges, you can have much faster solutions. The second counter to this objection that you cannot that you cannot solve problems in polynomial time is that we are not seeking to find optimal solutions, and this is something which many people have observed, that human beings are not optimizers. We do not necessarily find what solutions, the solutions that we consider to be optimal. We are what some people call as satisficers essentially, which says that you are happy with a good solution essentially. It does not have to be optimal essentially. So, just an example which sort of strikes me once in a while, living in Chennai, that if you are walking along one of the roads in IIT, maybe one thing that you want to optimize on the amount of shade that you walk through, but you do not have such dense trees that everywhere there is shade. So, you have to choose a path essentially, and even if one is conscious of the fact that one wants to walk through shade, and one does not mind walking a little bit longer, so that our objective function is to maximize shade and not worry too much about the length of our path. Even then we do not go into zigzag paths that we would if we were to really follow the shade essentially. So, we do not optimize in that sense. Even when we want to be away from the sun, we are happy that if the path that we are following has enough lot of shade, not necessarily the maximum amount of shade essentially. So, in that sense we do not solve hard problems completely, we do not find the optimal solutions, but we tend to find good solutions essentially, and that is what we do all the time. If you go shopping, you do not check in 10 places and then find the minimal cost price and then buy a product, even though on the web nowadays you can do that sort of a thing. But in general, if you think that the price is reasonable, we go and buy that stuff essentially. And one more definition, which is due to Charniak and McDermott, who also wrote a very famous book on AI, very popular book which I use for part of my section. I do not think I mentioned it, maybe I should add it to the list there. They talk about AI being the study of mental faculties through the use of computational models. So, we had said earlier that there are two approaches to AI. One is the cognitive approach, which says we are trying to understand intelligence, and the other is the engineering approach, which says that we want to build smart systems or smart apps, if you want to say nowadays. So, what this definition says is that we want to study mental faculties, and to do that we will build computational models and use them for the study essentially. The definition which I like most, and before I come to that, look at these definitions. They are saying if a human being does this, then it is intelligent, and we want to sort of do something similar. So, we want to mimic human intelligence. So, the definition which I like most comes from not a computer scientist, but from a philosopher that we mentioned, John Haugeland, in the book AI the Very Idea. He says that the fundamental goal of AI is not merely to mimic intelligence or produce some clever fake of intelligence. He says that is not the goal at all. AI wants the genuine article, machines with minds of their own in the full and the literal sense. Now, it is a very interesting question, and we will debate it today a little bit in the class as to what we mean by intelligence and can machines have it. And then he goes on to say, and all this is in this book here, that this is not science fiction, but real science based on a theoretical conception as deep and daring, namely that we are at the root computers ourselves essentially. So, if we are at the root computers ourselves, which means if we are at the root machines ourselves, then to answer the questions can machine think has been trivially solved essentially, because yes, human beings can think and therefore machines can think essentially. But the idea that we want to pursue is that the idea that thinking and computing are radically the same is the idea in his book, which is AI the Very Idea. It is a very interesting book, and for those of you who are philosophically inclined should go and have a look at it. And this idea that thinking and computing are kind of tied up together goes back much before Haugeland, and we will see either in today's class or in the next class that the British philosopher Thomas Hobbes was one of the first person to put forward this idea. Hobbes, of course, was not a computer scientist. In those days there was no computer science. He was a political scientist and this kind of stuff. Okay, so let us get to the fundamental questions, and this is the part that I want you to give answers to, or what do you think about this question. So, I have not written any answers for this, I have just written the questions, and I will write the answers on the board as and when they come out from the class essentially. Okay, so, the question we want to ask is, what is intelligence? I mean, if there is going to be ever a debate about whether machines can be intelligent or not, machines can think or not, first we should be clear as to what do we mean by intelligence. I mean, if I write a program which, let us say, does singular value decomposition of a matrix, is that program intelligent? Well, I do not know. So, can I have some responses from the class? What is intelligence? What is, let us forget about what is thinking, let us say. So, thinking is this thing, but when would something be called intelligent? Or what is intelligence? What would you require in a system or an agent for you to call it intelligent? What are the fundamental characteristics of intelligent behavior? Yep.
Maybe ability to make decisions.
Okay, that is very generic. Yes, definitely a part of intelligence, but maybe if you could expand on that one a little bit. For example, you have a small program which says if something then something else. It is also taking some decision by looking at some data. Obviously, you are looking at something and taking a decision.
Use of knowledge to respond to new situations.
Use of knowledge. Of course, you will have to tell me what do you mean by knowledge. And this definition has a little bit of inconsistency built into it, in the sense that most of the time when we use knowledge or experience, exploit experience, we use them in situations which are similar, which are not entirely new in that sense. Well, if by new situation you mean a new problem, then one has to ask the question, what do you mean by that essentially? There is this old saying which says that you can never step into the same river twice. Essentially, that it is never the same thing, but of course, nevertheless, I am not disputing what you are saying. I am just trying to get people to respond more. We do, as human beings, you make extensive use of knowledge, and we spend close to, what should I say, 22 years, 25 years acquiring knowledge which we will later use essentially in our lives essentially. Humans are a very different kind of a species, I think. I mean, we are the only species which has schools up to 12th standard and then college 4 years after that, and then masters and maybe even a PhD in some cases. No other species spends so much time acquiring knowledge essentially. Yeah.
To be able to make inductive leaps, I mean something which doesn't just follow from your input, but to be able to make some new
Okay.
assumptions.
So I'll just use the term inductive inferences, or in other words, to generalize. Ability to generalize, right? So you go to some hotel and you eat a masala dosa and you're happy, you come back. Next day you go there and you have something else, let's say uttapam, and you come back and then you generalize that this hotel gives you good food, or you might say that South Indian food is very good. These kind of inferences that we come to is making inductive inferences. We look at a few instances of something, and then from where we generalize that it holds for a certain class of things essentially. I see a few leaves and all of them are green, then I conclude that all leaves are green essentially, which of course is not true, at least not all the time. Maybe in Chennai, yes, when we have leaves, but not in the rest of the world.
Basically, extending that definition, ability to generalize and classify.
Yeah, classify would come in this making decisions, right? What else? I mean, is that all that we do as human beings? Is that all we lay our claim to for being intelligent?
Choosing the best available option.
Well, wouldn't that come here? Choosing best options.
Somehow the ability to learn.
Ability to learn. Yes, which is a little bit different from here. And we can say by learn we mean acquire knowledge. Yeah, one can learn from one's own experience. You do something which gives you a little bit of a pain. Maybe you touch a hot stove or something like that 2-3 times, and then you learn. That's again inductive inference essentially. But to learn all kinds of things, to learn facts, to learn relations between things, is something that we do quite effectively. So what do you mean by this? What do you mean by this? Communication. So, but there is a more fundamental thing to, I mean, expressing well something incidentally is something which is the feedback we get from all the companies which come to hire people here. They say that our students are not good at communications. But that's not the idea, that's not what you are talking about, I think. The very fact that we can communicate something. So let me go to the fundamental thing. What does this rely on? Something which is specific to the human species. Speech, but speech, before speech, use of language. Language is something which is unique to, at least we think it's unique to our species. There are doubts that maybe whales communicate over long distances and dolphins can communicate and that kind of stuff, but we are not quite sure. And we do see that there are other creatures which make sounds which are obviously aimed or directed at least towards their own species, but it's not clear to us what they are doing essentially. So it is a use of language which has enabled us to carry forward knowledge. So, if you have a brilliant scientist like Newton, who is thinking about the universe and the world around him and coming to conclusions and arriving at some understanding of how the world operates, the fruit of his effort is available to us, and it is available to us only through the medium of language essentially, because we can talk to other people, because we can write books. So, printing of course was another invention which helped this process, but just simply be able to communicate, to tell stories. This whole idea of folklore, that stories are passed on from one person to the next, like all the stories that we hear in our subcontinent, the Ramayana, the Mahabharata and so on, were sort of orally conveyed from generation to generation, and all that is possible entirely through the use of language. It is language which has allowed us to hold on to whatever knowledge we get from our interactions with the world and pass it on to other people essentially. Anything else can one think of? Okay, so we will take this as part of thing, and then we will see whether machines can be intelligent. So, let me move on a little bit and ask the next question. This is not a very complicated question. I just want to be sure that we are all on the same page, because when we talk of machines thinking and so on. So, what do we mean by a machine? Because otherwise, we will be stuck with trying to answer a question that can machines think without knowing what we mean by thinking and without knowing what exactly we mean by machines. So, both these terms we should know as to what do we mean by that essentially. A device which does a particular task repeatedly. Okay, I am not going to write this here. Is that a complete enough definition of a machine?
A device that does reduces human effort.
A device that reduces human effort. What about an exercising machine? A treadmill or something like that?
Computations.
Something that does computation, but computation is only one kind of activity that we consider. You have a machine which grinds coffee beans for you. I don't know whether that is doing computation. No, more fundamentally, when will I call something a machine? That is what I mean by the question essentially. So, if it is not a machine, what can it be?
It follows the given instructions. You instruct it and it will do the work for you.
Doesn't think on its own.
So, he says that it does not think on its own. So, he is trying to give the answer to the question that can machines think. So, machines are things which cannot think on their own. Yeah. Now, this bit about following instructions, I do not know. I mean, there are, of course, at some stage in the life of a machine, there are instructions given to a machine. So, but if I have a air conditioner like in this room or a thermostat somewhere, it is not really following instructions.
But some coding or something.
At some, yeah, that is what I said. At some stage in its life, some instructions were given to it. But then I can say the same thing about you as a person, right? That you are following instructions. Your parents said, go and attend lectures, don't bunk classes. So, you are sitting here. Yeah. No, more fundamentally, what is, when would I call something a machine? So, let me give a circular definition. Something which acts mechanically. Of course, as I said, it is a circular definition. It is using the term machine and mechanical, they are related to each other. So, it is not really a good definition in that sense, but it gives us an idea of what I am trying to convey essentially. Because we can express this more easily. When do you say that something is acting mechanically? And I do not want to answer that without thinking, because thinking is something which happens at a different level altogether, as we will see. basically in a well defined manner according to certain rules, let us say laws of physics if it is a physical machine, or some other mathematical laws if it is a computing machine, something which operates according to fixed set of rules. Okay. So, the question that one asks is and we will come to that in a moment. Okay. So, this is a question which has raised. So, just to be clear, is a computer a machine? It does operate according to some very well defined laws and so on. Of course, a computer is a very special kind of a machine, it is a very flexible kind of a machine which says, so this whole idea of stored program which we discovered, it was discovered not quite discovered, but at least brought forward by Charles Babbage, which says that you can have the same machine and you can put in a different program and it will do something different for you essentially. It makes it a very flexible machine, but nevertheless it is a machine because at the base there is something which is very repetitive which is going on. And whenever we say machine in the rest of this course, basically we will mean a programmable computer. So, when we say can a machine think, then it means can we program a computer so that it appears to be thinking or is thinking as the case. So, this is a question that is fundamental in the sense there was a raging debate, as we will see some arguments against thinking in the next slide. In the last 50 odd years, 60 years, people have been talking about whether machines can think or not. So, does anyone here have a strong opinion either side? So, when I say by this time I mean a computer program, can I program a computer so that it is a thinking machine? Is that possible at all? And we try to find some aspects of what we call intelligent behavior. Or is there something missing that we have not mentioned here, we forgot to mention here, which the computer cannot do, can never do? Is there something like the halting problem situation here? So, does anyone have an opinion either ways? Does anyone strongly feel that yes, machines can think, there is nothing fundamentally against it? Or does anyone have an opinion which says no, machines cannot think, only we human beings can think essentially?
So, but you didn't tell what is thinking.
Well, that is the first question I started asking you with. So, we wrote all this stuff by saying that if you are doing this
Intelligence, right?
Yeah. So, we sort of say that they are closely correlated. Thinking is the process out of which intelligence arises, you might say. So, no one has a strong opinion, I take it essentially. I think. Okay, so that is fine, there is nothing either ways. And finally, as Hogeland said, I mean what Hogeland thinks about this question, that are we machines, is already there in his answer essentially. He thinks that we are machines. But is there anyone here who feels that strongly about this, that yes, we are machines, or no, we are not machines, we are flesh and blood creatures of carbon, we are not made of silicon? Any strong views? So, supposing I were to say, okay, let us try and put forward the idea that we are machines, what is the argument that you would give to say that yes, we are also machines? Okay. So, one of the fundamental objections that people ask is that machines versus whatever it is which is called as free will. So, when I asked you a little while ago as to what would be if you were not a machine, then the answer that some people gave is that you have your own free will. So, in some sense a machine does not have any free will essentially. A machine operates according to fixed set of instructions and fixed set of laws and always obeys those instructions and laws essentially. Whereas free will, which we do not understand, we do not know whether we have free will or not. I mean, people claim that human beings have free will, but they all go and vote for some Congress and BJP all the time. essentially. So, but anyway, what is this thing called free will? Basically says that we make choices, that we are the ones who decide how our lives will be or what we will do in the next instant and things like that. European philosophies like existentialism dealt quite a bit in the post war period about this notion of free will and making choices and things like that. So, if we were machines, then we would not have something called free will, or is that a contradiction? Or if we are machines, do we, like some of the Indian thought says, that everything is pre-decided? Like they say, whatever had to happen will happen essentially. Of course, then we are all machines, and then there is no second thought about it. But if I were to sort of deconstruct and say, okay, we are machines because of this reason, I could sort of give you an argument which says that we grow out of a single cell to start with instructions written in our genetic code about how to build our bodies, what color of eyes to have, all kinds of things. And then essentially we build ourselves using this thing, and therefore we become human beings. And just like computers are flexible and they can do different things at different times, we are also flexible, maybe a little bit more than the current day computers, but we are, in the end, we are machines essentially. Or I could give you an argument which says that, see, our brain is made up of 10 to 100 billion neurons. All of them operate by a very simple mechanical procedure. So, our brains are mechanical in nature, and therefore, since the brains control us, we are mechanical in nature. I could give arguments like this. So, what would you say against it? I mean, if you were to say anything against it.
We have something called emotion that is not in machines.
We have something called emotion that is not in machine essentially.
We are biased to our emotion.
But how do you know it is not in the machine?
Suppose I turn off my computer.
Supposing your system crashes, can we say it is angry with you? I mean, it may not display it in other ways, I think. No, more seriously, why should you say that machines cannot have emotions? I think. So I will point you to a book. It is called The Emotion Machine. And it is written by a guy called Marvin Minsky. Marvin Minsky was also one of the founders of AI. As we will see the history of AI as we go along, he founded the MIT AI lab along with John McCarthy, and he has, in the last 5 or 6 years odd, he has written this book called The Emotion Machine essentially. So it actually it takes us into again a slightly longer debate as to what do you mean by emotion and so on and so forth. I could try to characterize emotion by saying that you have memories, and then you have some value labels attached to memories, that some memories are good, some memories are bad, and then you have states which are attached to those value labels. So, you are happy or you are sad. So, one could talk about things like that, but is it something which is exclusive to us? I do not know. And do creatures like dogs and cats have emotions? They have. But are they also intelligent, or that is another question. Is intelligence the prerogative of human beings only, or do we allow dogs and cats and deer and monkey to be intelligent or not? Yeah, but if you go down this ladder of life, so to speak, then you have dogs and cats, then you have mosquitoes somewhere here, then you have bacteria, then you have virus. So, at which point do you stop? Interesting question. Okay, we are not here to answer these questions. We are here to keep in mind that these questions have been asked by many people, and this is not the goal. Our goal to it's not a course on philosophy, but still we should be aware of it. So, here is a small cartoon I got from. So, if we were machines, yes, then I suppose our admiration would be mutual, I think, or if you want to call it admiration. So, let me give you some arguments which are well known in literature, which claim that machines can. The question we are asking is, can a machine think? Can machines think? So, what are the objections? The first, by a guy called Herbert Dreyfus, says that intelligence depends upon unconscious instincts that can never be captured in formal rules, essentially. So, you can't read this. I didn't know how to make this a bit stronger, darker. This is basically a Wikipedia page which is critics of AI, essentially. Dreyfus spent he has made a career out of saying that AI is not possible, essentially. So, at least he has made a career out of it. What do you think about this? Unconscious instincts that can never be captured in formal rules. So, this is one of the arguments which people say, these kind of arguments which says that we often do not know what we are doing, why we are doing something. I did this, but I did not know why I did this. But does this say that I was doing something really mysterious which I cannot reproduce in a machine? Let us look at the argument by philosopher John Searle. It is called the Chinese room argument. He says, can an agent locked in a room processing questions in Chinese based on a set of syntactic rules be said to understand Chinese? So, it is a thought experiment which John Searle proposes. It is a very famous argument. Just look up the Chinese room argument on the web and you will get all these descriptions. So, the idea is that supposing you as an English speaking person or whatever, Hindi or Tamil speaking person, were locked up in a room and you were full of these slips of paper which have these syntactic rules which say, if you see this pattern, then send out this response. If you see this pattern, then send out this response. Okay. You do not know what that thing is about. You see some patterns and you have been instructed to match a pattern and send out a response based on that. And there is somebody from outside below the door sending you slips of paper with some patterns, then you make some other patterns on slips of paper and send them back, essentially. You do not know what is happening, but it turns out apparently at the end of this is that somebody is asking you questions in Chinese and you are giving them answers in Chinese. So, John Searle says, and this is his Chinese room experiment, thought experiment, says that supposing this were to happen, would you say that the person who is answering you knows Chinese? And he says no, because the way that experiment has been described, and he says that therefore, but his behavior looks like intelligent behavior because he is giving you all the answers, but is that real intelligence? He says no, essentially. But of course, there is a little bit of an operational trap there, which is what I have written here. How many rules will an agent need to have for the thought experiment to be convincing, essentially? And we will see this idea again in a different form as we go along. Okay, one more objection from the celebrated mathematical physicist John Roger Penrose. You must have heard about him. Also a Nobel laureate. He wrote this book which became quite a hit, essentially. It was called The Emperor's New Mind, essentially. Let me write the name here. So, parodying the emperor's new clothes, and he is also asking this question about can machines think or not. His answer is that no, machines cannot think, we are the only thinking creatures, and he says that there is something happening in our brains which current day physics cannot understand, cannot explain, essentially, and that is something he says with respect to quantum mechanical If you want to go into those details, you should look up the web or read his book essentially, which is not so easy to read. But still, he wrote a later book, I forget its name, which is a shorter version of this book. So, that is another argument. Then there are arguments like he mentioned emotion, intuition, consciousness, ethics. So, some people say it would not be ethical to have intelligent machines, so they cannot be intelligent. Now, this is kind of a roundabout argument which says it would be bad for I do not know who, so we cannot have intelligent machines essentially. Of course, we are very ethical people, and we go around suspending 28-year-old IAS officers because of some small prejudice that we have against them. So, there are many arguments which occurred in nature, and there have been many counters to the argument which I have not talked about, because we want to get on to what Turing said. Right. So, you all know Alan Turing. He was very instrumental in cracking codes during World War. This thing. What he says, that he would have been 101 years old if he were alive today. Right? What he says, last year was his birth centenary and lot of things were going on. He says that the question whether machines can think is just a meaningless question, because we are not able to even describe. We made an attempt here to say what is thinking, but it is not very clear to say what is thinking. I mean, IQ tests and things like that are of course meaningless essentially, as is I guess JEE and SAT and something. What he did was that let us not get into this raging debate of can a machine think or not. He says, I will give you a test which he called as the imitation game, which we will see in the next slide, which is now known as the Turing test. There is nothing to do with Turing machines. Of this he says about this Turing test, we will see in a moment, or let us first see the test and then come back. The Turing test is like this, that there is a human judge. No, this something has happened to this anyway. There is a human judge sitting on, in those days a teletype, in current day world maybe on a mobile phone chatting with someone. So, you are chatting with someone, you type in something and somebody else types back something, and so on and so forth. So, he imagined the teletype connected to a machine on the other side, but there is a wall in between. So, you do not know whether it is a machine or whether it is a human being. And what Turing said was that if he gave a figure like 70% of the time the machine can fool the judge into thinking that the judge is talking to a human being, then the machine is intelligent. So, we will come back to the test again. So, what did Turing feel? He felt, and this was in 1950 when he wrote this paper called Computing Machinery and Intelligence. It is available on the web. If you go to many places, you will just get the paper directly. He says that in about 50 years of time, which is 2000, in year 2000, it will be possible to program computers with a storage capacity of 10 raised to 9. So, 10 raised to 9 was considered to be a big number, and history is replete with these kind of examples. Right? Bill Gates apparently had once said that who on earth will need memory more than 64K essentially. So, he said that with a capacity of 10 raised to 9 to make them play the imitation game, the game that we just described, so well that an average interrogator will not have more than 70% chance of making the right identification after 5 minutes of questioning. And then he says that I believe that at the end of the century, which is at the end of 50 years, use of words and general educated opinion will be altered so much that one will be able to speak of machines thinking without expecting to be contradicted. It is very difficult to make predictions in these kind of matters. David Levy said that no machine can beat him. Alan Turing says that all machines will routinely pass the Turing test. Both were wrong in the sense that we still can't say that we have machines which pass the Turing test. So, currently there is something called a Loebner prize, which has been instituted by a guy called Loebner, as the name suggests. It is an annual competition where chatbots are judged by for human like response. So, it is not as if you are fooling something, but for human like response, and there is a grand prize of $100,000 in case you are interested in some pocket money, but it's still open essentially. So, there are two. So, there is a question which I want to ask of you. We do not have too much time, we will have to stop soon, and we will start with this in the next class. Is to what do you think of the Turing test as a test of intelligence? Remember, though he himself said that do not talk about thinking and all, but just accept this test. Let me just show you some examples of this year's competition, which I got from the web. So, this year there are 4 finalists who are going to compete on September 14. These finalists have been selected based on some earlier rounds, and this is a transcript from the leader of those 4, the best known. So, let me just read it out. So, there is a judge and there is this program called IZAR. So, the judge says, hello, I am Ronan, that is the name of the judge, what is your name? The program responds, and just try to imagine how would you write a program which would respond like this. This is the output of this program, which is called IZAR. It says, Ronan, it is about time you contacted me, I was waiting for you, my name is IZAR, pronounced IZAR, but you can call me easy if you want, doing anything fun, too much recursion in AIML, and so on and so forth. Judge says at some later point, I have not given you the full this thing. I like bananas, which is your favorite food? He says, tell me more about your unknown. Okay. This is a trick which the program is employing to answer a question which is it cannot answer very easily. You are not only one, so you have to build in these kind of tricks. Human beings also do that. If you are taking a viva about something, you have seen it. So, I do not have a problem with bananas. Is that your favorite food? The obvious one, and so on. Then he says, I have been getting into Humi, a type of Mongolian throat singing. So, you have to put in certain amounts of knowledge in your system to be able to convince the this. Okay, so he is trying to impress other way. So, let me leave you with a program which was written in 1960 or something. This program was called ELIZA. You might have heard about it. It was named after Eliza Doolittle, who was a character in Bernard Shaw's play called Pygmalion, and we will visit Pygmalion again later. It was a very simple NLP program written at MIT by Weizenbaum in 1966. It used simple rules to manipulate language. It would read what the user has written, manipulate it little bit and throw it back. So, it says if you go and say, for example, somebody will say, so for example, if you were to say, oh, I like bananas, it would simply say, why do you like bananas? So, it just twists that and send it back to you. And there is a popular version called Doctor, which I am sure you might have seen. It runs a script which makes it looks like a psychotherapist essentially, which of course makes it easy to ask questions. So, it can always, one of the standard questions these programs ask is, tell me more about your family. If they can't say anything else, they will say, tell me more about your family, and as a human being you would say, oh, this program is doing some deep analysis. So, here is a Russian scientist who was visiting Stanford, who was running a version of this. So, just read this. So, I have colored those things to show you that it is just twisting that sentence and this thing. So, so there was a scientist apparently after this conversation he started pouring out all his woes to this program and so on and so forth, and Weizenbaum found that his secretary was all the time talking to this program, and apparently she was quite furious when she found out that Weizenbaum had access to those conversations. But nowadays, of course, Prism and everything. Weizenbaum actually found that people's responses were so disturbing that he wrote a book which says that no, computers cannot do all these kind of things essentially. So, we are gullible, and I think we will take it up in the next class with some even older examples of how we look at something and we believe that it is doing something intelligent for us essentially. Meanwhile, I would like you to think about this Turing test. In the next class on Wednesday, we will start discussing